Hey guys, hopefully this message finds you all healthy and safe at home and ready to move on to our next topic of algebra review to get you ready for Algebra 2 next year. This week we're going to focus on the distributive property, specifically something we call the FOIL method. It's a way of using the distributive property twice, essentially in one problem, and distributing over addition. It comes into use on problems something like these. The first instinct on this is to say, well, if I multiply x plus 3 times x minus 5, I'm going to get x squared minus 15, right? That's kind of like everybody's first instinct. But that's not exactly how this works, because what we actually end up doing here is we have to use the distributive property. And I'm going to go ahead and break this apart. And you don't have to do this on every single problem, of course, but I'm going to go ahead and do that on this one. What happened here? So I can show you what happens here and why we have to distribute, or why we have to use the process that we do. X plus 3 times x minus 5, that's the same thing as taking x times x minus 5 plus 3 times x minus 5. Okay, that's taking this whole thing right here, and we break it apart. Take it x times this, and we take 3 times this whole thing, not just the first part of it. And then when I finish this off here, now I distribute the x, and I distribute the 3, giving me x squared minus 15, or minus 5x, oh, where did I get 15? Minus 5x plus 3x minus 15. And then notice these two terms here are alike, negative 5x and 3x, giving me x squared minus 2x minus 15. And you say, well, I don't want to go through that whole process every single time and splitting apart that first one and multiplying it times the x minus 5. That takes a lot. That's where the whole acronym FOIL comes into play, F-O-I-L. Now, typically, math teachers don't like to teach FOIL, and to be honest, I'm not really real keen on it either, but the thing that does come into play on this is that if I'm multiplying a binomial times a binomial, it does work. Now, if you remember, a binomial is when I have two terms right here, x plus 3, there are two terms here. X minus 5, there are two terms here. And so that is a binomial times a binomial, so I can use the acronym FOIL. And what it stands for is first, outer, inner, and last. And what it does is it helps remind you to multiply all of the correct terms in a expression when you're multiplying a binomial times another binomial. And on this next example, I'll show you what I mean by that. I've got 2x minus 7 times x plus 5, and I'm going to use the acronym FOIL. And again, I'm going to write it out here. First, outer, inner, last. And I'll use a little color here to help us on this. The first one is first. That means I take the first term times the first term. That's my first. So I take 2x times x, which is 2x squared. Then I multiply the outer terms. That is 2x and 5. They're on the outside. I'm going to move this down a little bit so I have room to write. And so I take 2x times 5, which is 10x. Then I multiply the inner terms. That's these ones here on the inside, 7 and x, which gives me negative 7x. Those are the inner terms. Put a little I there for inner. Then I multiply the last terms. That is the 7 and the 5. The last terms, negative 7 times 5 is negative 35. And then our last step, notice here in the middle again, I have like terms. And so I can combine those like terms. I'm going to have 2x squared. 10x minus 7x is positive 3x. And then minus 35 on the end. And so there is our final answer. Okay, that's using that acronym, first, outer, inner, last. And it's just a way of reminding us that I need to make sure I multiply all of the correct terms together. And again, this only works if you're taking a binomial times a binomial, or it's 2 terms times 2 terms. Now next year we'll start getting into things where it's 3 terms times 2 terms, or even 3 terms times 3 terms, and then FOIL, the actual acronym, doesn't really work, but it's still the same concept. You need to multiply all of the values times the other one in the other expression. We'll get to that next year in Algebra 2. Okay, so here's another example, x plus 6 squared. Now again, initial instinct to say, oh, well, that's just x squared plus 36. Well, that's not really the case, because, what happened here again? Did it again. It's not really the case, because x plus 6 squared is x plus 6 times x plus 6. Okay, and so that means, again, I need to use distributive property or the FOIL method to get there. And so I take x times x, which is x squared, and then I take 6 times x, which is 6x, and then I take 6 times x again, which is 6x, and then I take 6 times 6, which is 36, and then combine like terms to get 12x in the middle plus 36 on the end. Okay, so again, remember to use the distributive property again on there. You don't just distribute the squared in and make it x squared plus 36, because then you're forgetting the middle term of 12x, and you don't want that. So one last example I've got for you, something that looks like this. X minus 12 times x plus 12. And again, we're just going to use the FOIL method or distributive property again on this. I just want to show one example like this, because when I start multiplying things out here, multiply the first terms, x times x is x squared, and then outside 12 times x is 12x, and then the inside negative 12 times x is negative 12x, and then the last terms, negative 12 times 12 is negative 144. Look what happens to these terms here in the middle. Positive 12x and negative 12x, they cancel each other out. And so I'm just left with x squared minus 144. Okay? This will happen occasionally. Whenever you have the two binomials, x minus 12 and x plus 12, being exactly the same except the sign different, then you'll end up having those middle terms cancel each other out. And there actually is a term for this. This is called a difference of squares. The reason why it's called difference of squares is because if you look at our final answer, x squared minus 144, x squared is a perfect square, 144 is a perfect square. You have a difference of squares. You have a subtraction of 2 squares as your final answer. And so that's just a special situation that you'll come across that, again, when we start factoring, this is something that will really come into play. Whenever you have a difference of squares, it's going to result in the subtraction and the addition of their square roots. And we'll get into that next week. So if you have any questions, feel free to join me on Zoom this week, and I will be happy to answer them. Again, hope everybody's staying home and staying safe and staying healthy, and I will talk to you guys later.